Okay, so here is our first video that I am recording for Math 125. Uh, this one is just to be going over some of those first problems. This was from homework item number 2, actually, here. The first one was the syllabus questions. This is one you did in class, and we are, but this video is optional. You can watch it to check your answers, or if you didn't know how to do these and you were struggling with these, this will hopefully help. So let's get started with this first one here. In this one, there is a fraction where you have something divided by 3, and then it's multiplied by 3 here. There's a couple ways you could think about it. One way is you could just cancel it out and get -7 plus 25, because dividing by 3 and multiplying by 3 cancel each other out, and that's fine. Another way you could think about it is that the 3 gets multiplied by the top of this whole thing, and that will turn it into something like this, where you have -7 plus 25 times that 3, and then divided by 3 again. And then the 3's will cancel each other out that way too, because it's a factor in the top and bottom of the fraction. In any case, you just get -7 plus 25, also known as 18. Then this next one, it's a little bit different because you're not multiplying 3 by a fraction exactly. You're multiplying 3 times this whole thing. And in that case, if the two things are separated by a plus here, you need to distribute the 3 over that, like so. Multiply that fraction by 3, multiply the -7 by 3. And then the -7 times 3 is just -21, as usual. The divided by 3 and the times 3, they should be canceling each other out just like they did in the last one, and so that just becomes 25, and the result that you get is -21 plus 25, and that is 4. The important thing to notice about these problems is that the first one is all one big thing divided by 3. The whole thing in parentheses that you're multiplying by 3 is one fraction. Here, it's a combination of two things being added together here with that plus. All right, let's go on to part C here. This one, when you have each of these being multiplied by this 2 here, that means you can factor out the 2 using the distributive property. You write the whole thing as something times 2, where what's on the inside is the 10 plus 7 minus 14 that was left over. And because when you have this whole thing in parentheses times 2, you could think of it as just distributing it back in if you want to. Distributing it times the 14, times the 7, and times the 10, and that gets you the same thing you just had. And then, of course, the whole thing is still divided by 2, so when you have the 2 in the top and bottom as a factor, it cancels out, and you get 10 plus 7 is 17 minus 14, leaves you with 3. And, okay, same idea with this one, except the problem is that you can factor a 2 out from this part, the 10 times 2, and you can factor a 2 out from 14, that would be 7 times 2, but 7, you can't write that as 7 times 2. So this previous method doesn't work. What I'm going to do is, one way you could do it is just add it all up in the top and turn it into 10 times 2 is 20, plus 7 minus 14, all divided by 2. That becomes 27 minus 14, which is 13 divided by 2. And you could either leave it like that, that's a fine answer, or you could write it as 6.5. So for part E here, the straightforward way to do it is just to do it in the order that's indicated, which is to do the 18 plus the 7 first, which is 25, and then do that, minus 7, and 25 minus 7 is 18. So there's that way to do it. Or, of course, you could also use the associative rule, which will allow you to move the parentheses around. When you have things being added like this, generally you can take these parentheses and write it as 18 plus the 7 minus 7 first. So moving the parentheses to right here from where they were before. And then, of course, 17 minus 7 is 0, and it's just 18. So that's the associative rule is what that's called, but it works either way. So let's go on to this one. In this case, it looks like there's a 7 minus 7, but that's not exactly how it works, because the order of operation says that you need to multiply the whole 18 plus 7 thing here by 2. This is the thing that needs to happen first before you can do that subtraction. So to do that, you could either distribute the 2 or do 18 plus 7 first. Let's distribute the 2. It's going to become 2 times 18 is 36, plus 2 times 7 is 14 minus 7. And then you see, if you did the 7 minus 7 before, a common mistake, you'd be making a mistake here, and you'd be missing out on the 14 minus 7, which is 7. Anyways, the whole thing works out to 43. All right, this one, 3 squared plus 5 squared. 3 squared means 3 times 3. 5 squared means 5 times 5. So that becomes 9 plus 25 is 34. All right, but now what if you have the whole thing 3 plus 5 squared? Well, the order of operation says that we should be doing what's in the parentheses first, whereas the other time we were squaring it first. We did the 3 squared and the 5 squared to do that step here. Now this time the 3 plus 5 becomes 8. And then we have 8 squared, and 8 times 8 is 64. So I wanted to give you guys this exercise to point out that these are different things. It's a common mistake. That thing and that thing are very different. Okay, so that's the end of that problem. Let's go on to number 2. Okay, here is number 2, still from the first do item from the section 0.1, Basic Equations and Graphs. Now, Basic Equations and Expressions. So we're still evaluating expressions, not actually solving anything yet. So this time we're just going to be plugging in for x some numbers. So for example, I'm going to replace this x everywhere I see an x with 3. So that will make this expression here turn into 3 over 6 plus 3 over 2, and then still times that x there, that becomes times 3. Now, there's a couple ways you could do it here. You could choose to either one way distribute the 3 into it. You could do that, or maybe let's try to add these first. I'm going to do it that way, where I'll take this whole thing here and try to write that as one fraction that we can multiply by 3. So first of all, the 3 over 6 you can reduce as 1/2. So that becomes 1/2 plus 3/2 times 3. And the 1/2 and the 3/2 are the same kind of fraction. They have that common denominator there, which means you can combine the tops to become 1 plus 3, which is 4 over 2. Still times 3. 4 over 2 is 2. So the whole thing becomes 6. Alright, so for part B, we're going to replace this x here with -3, because it says that x should be -3, and so we're going to evaluate this expression. So this becomes 4 plus -3 here, squared. 4 plus -3 is just 1, so you've got 1 squared, which is 1. And this time, the difference is that instead of it being plus, like it was over here, this time we've got a minus here. So what we're going to have is the x is still going to be -3, but the whole thing is going to be 4 minus -3 squared. And because there's still this plus here, that minus a negative number becomes plus, and it becomes 4 plus 3, which is 7 squared, which is 49. This time we have x squared, but the thing is x is a negative number. So when we take this x and square it, the x is, just like before, going to be equal to -3. And that's what's being squared. And then -3 squared means -3 times -3. And that, because there's two negatives being multiplied, of course it becomes a +9. So you get +9 as the result with that one. Now, this one, we know that this x squared thing, this whole thing here, when x is -3, that whole thing is just going to become 9. So we could think of this as just 10 minus 9 and get 1 that way. And that's a fine way to do it. This one, we're plugging in -7 into this. Lots of practice with negative numbers here. So I'm going to replace this x here and this x here. Each are going to become -7. So we have -7 minus -7 times -7 plus 4, and a negative number minus a negative number here being subtracted, those cancel out, and so you just get -7 plus 7. And here, -7 plus 4 becomes -3, and we get 0 times -3, which is 0. Here is some from the next item. This is still part of Basic Expressions and Equations, section 0.1, but this is from item number 3. At least it's item number 3 so far, but I might change that. Maybe I shouldn't be putting that in video forever. But anyways, what we are trying to do here is more stuff about the basic vocabulary. Is a solution of an equation is a value that when you plug in this value, it should make the equation true. It should actually make both sides equal. Let's try that with A by plugging in 5/3 wherever you see the y here. That should make this whole thing become 6 times 5/3 plus 10 equals 12 times 5/3. And what we want to know is this actually true? Are both sides actually equal? Is what we want to see. So let's work it out. First of all, 6 is 2 times 3, right? So you can write that 6 times 5 times 3 as 2 times 3 times 5 times 3. And that way you can see the 3 and the 3 here will cancel out. And same thing with 12, you can reduce that by turning 12 into 3 times 4. And then something times 3 divided by 3 cancels out. And so the whole thing will become 2 times 5 is 10 plus 10. We want to see, is that equal to what we have on the other side? The 3's canceled out, so we have 4 times 5, which is 20, and 10 plus 10 is equal to 20. This is true. So the answer to the question is yes, 5/3 is a solution. This is a really important thing to know how to do, because anytime you solve any kind of equation, you can check it. It's also important because it makes sure that you know what a question is asking for. We're going to have a lot of questions that say solve an equation, and there's a lot of different ways to do that, but whatever weird method you use to get a solution of the equation, it's important that you know what that actually means. That it means that whenever you plug that in, it makes both sides equal. It makes the statement that the two things are equal true. So that's an important thing to know how to do. It's one of the things I call one of the fundamental skills in the syllabus, so it'll come up a lot. Let's practice it again here with this 9/4 for x. So I'm going to replace each x I see with that 9/4. Another way, I just want to point out that you could deal with these fractions. I'll try to show you a variety of different ways to do things, because we're going to need to do different things in different situations. So one way you can do this is, 4 is really 4/1, and 8 is really 8/1. So if you want to see how these multiply, you could turn the 4 into 4/1 times the 9/4. And that way you see a fraction times a fraction, you know that means multiply the top and the bottom. I'll deal with that in a second after I copy everything else. And then likewise the 8 is 8/1, which we're multiplying by 9/4 there. So when you multiply these, we're going to get 4 times 9 is 36. That's the numerator of that fraction. 1 times 4 is 4. That plus that 9 from here still equals 8 times 9 is 72 divided by 4. And let's see What happens? 36 divided by 4 is 9. 72 divided by 4, I think, is 18. Yep. And remember, what is the question asking? It's asking, is 9 over 4 a solution of this equation? That means when we plug in 9 over 4, does it give us a true statement? And this here is a true statement. So yes, x equals 9 over 4 is a solution. Okay, moving on to part C here, plugging in the negative 1/2 for u. And we want to see, is this equation true after the value of u is plugged in? So you could do this 8 times negative 1/2 however you like. Maybe let's say that 8 is 4 times 2. You have that times negative 1/2. And here you can see that you are dividing and multiplying by the same thing. So those will cancel out. And same thing here. I see a 2 in the bottom, so I'm going to write that 6 as 3 times 2. And then those 2's will cancel out. And what's left over here is going to be 4 times negative 1, which is negative 4. We want to know, is that equal to 3 times negative 1, which is negative 3? And the answer is no. This is false. It is not true that negative 4 is equal to negative 3. So that means that negative 1/2 is not a solution. Here is number 2 from that same section. Let's see, these ones should be pretty quick. We're just seeing how does canceling things out work in general. Just a little bit of review of that stuff. This is all from beginning algebra, of course, so these should be pretty quick. If not, you probably need to get some help. So let's look at this first one. Here we have a negative 7 and a 7 being added together. In this case, all of the operations here are addition and subtraction, so it doesn't really matter what order it happens in. So you could think of this as just negative 7 minus x plus 7. The parentheses there weren't really doing anything because it doesn't matter whether you add the 7 first or not. So anyways, those cancel out, the negative 7 and the 7, so you're left with just negative x. And for part B here, you have a thing in parentheses here. This whole thing is getting multiplied by 2/3. The thing in parentheses has 2 terms that are separated with plus here. So the 2/3 needs to get multiplied by both of those fractions. So that's going to be 15 times 2/3 plus 3x over 2 times 2/3. And let's see. Now when you cancel this out, you can do it whichever way you want. Another way to see this is that I'm kind of doing it differently with all the different examples, just so you can see the different things you can try. Is you could write this as 15 over 3 times 2, because you know something will cancel out that way. That's the same thing as 15 times 2/3. And I'll deal with this other term in just a second, because the 15 over 3 is just 5. So this whole thing results in 5 times 2 there. And then here, if you have a 2 on the bottom here, that will cancel out with the 2 on the top that it's being multiplied with. And then this 3 should cancel out with that 3. So you should just be left with x over 1, also known as just x. So the result, the whole thing, becomes 10 plus x. And I wanted to have these together so that you can see that, just a reminder that there's no distribution here. When you have, there's two things being added or subtracted inside here, but then this is a plus 7, not times. So there's no reason to distribute that in there. There's just 3 terms being added here. The distributive rule happens because you have multiplication there instead of plus. Okay, so let's look at this one for part C. First, I want to just warn you something that you might do, which is a mistake, is you might say, oh, there's a 5 in the top and a negative 5 in the top and a negative 5 in the bottom. So can't we just turn it into x minus 10? And the answer is no. That is not correct. Let's see why. Basically, that 5, that negative 5 in the top, is only a factor of that one term here when you cancel it out that way. It's not a factor of the whole numerator. And to cancel out a fraction, it has to be written in this form, something like a times b divided by a times c, and that has to be multiplication. And then you can cancel out the a's and get b over c. But the top of this is not written here as negative 5 times something because there's this minus in between that messes it up. So to write it as multiplication so that you can use that rule, this is going to become negative 5 times x minus 2 after you factor it out. Now you have a multiplication here, just like you need to have in order to cancel something out. And that's divided by negative 5. And remember, negative 5 you can think of as negative 5 times 1 if you want, just to see that there's a 1 left over. So you get x minus 2 over 1, also known as x minus 2. Okay. And that's what that is. So let's see. Now let's take this 48 here and distribute that into these terms, because you have 48 being multiplied by 3 terms. You need to multiply it by each of them using the distributive rule. So we're going to have 48 times x squared over 24 plus 48 times x over 48, and you have plus 48 times 3/16. And just want to make sure stuff cancels out here properly. The 48 here is also known as 2 times 24. So that way you can make the 24 here cancel out with that 24. And then here, this other 48 is just 48 times 1, so that will just cancel out and give you just plus x. And 48 is 16 times 3. So let's write it that way. 16 times 3 times 3/16. And here you can see the 16ths will cancel out. because you have it in the top and the bottom of that. So the whole thing should become 2x squared plus x plus here, you're left with 3 times 3 is 9. And that's all you can do with that. Now, if you are struggling with these, you probably need to do a bunch of extra basic algebra practice. I recommend doing it at khanacademy.com. I'll post a link to a good place to start in Khan Academy where you can practice these, and that should hopefully bring you back up to speed here.